Hi everybody, thank you for watching. In this video, we will study the rules of the relational databases. As we had discussed in previous lecture, there are several types of database systems. For our course, we will be studying the relational database systems. Let us refresh our minds about some concepts from relational databases. So we say that a relational database is a set of relations, or instead of calling those relations, let's say tables. We will study 4 rules of the relational databases. For rule number 1 is the rule that we're going to call first normal form, or we just want to say 1NF. So this rule states that we cannot have multi-value attributes in a table. Here we have an example of a table that makes a reference to employees. So for employees, we want to keep a record of their social security number, their name, their age, but we also want to keep a record of the dependents. Maybe for this company, the company will provide some maybe benefits like health insurance, and we need to have a record of the dependents for the employees. Now, for the first record, we see that the employee has 2 dependents. Now, this is a problem with rule number 1 because here we got 2 values for attribute dependence, and this is not allowed. So here we got 2. So this is okay because we have 1, but this has 3. We will study then 3 possible solutions for this problem. Solution number 1, we're adding additional columns to the table to solve the specific problem that we have for the table that we were discussing previously. For example, Bill has 3 dependents, so now we have a way of storing those 3 dependents in each one of the columns. Now, the second employee had only 1 dependent and we're not using this space, right? And then the same for the first one, we got 2 dependents and we're not using this space. Now, this is solving the issue about multi-value attributes, but then we will also notice that it's difficult to decide the number of columns that we need to add. For this specific example, we got a maximum of 3 dependents, which is solving the problem. But if in the future we get a new employee that has, for example, 5 dependents, then we're going to have a problem on recording those 2 extra dependents because we only have a space for 3. Unless the company establishes a rule that says we can only hire new employees with a max of 3 dependents. Okay, so that will maybe not be a good solution. Now, the other thing that we noticed was that we were wasting some space. So if for this company we have, for example, most of the employees, they just graduated from college and they have no dependents, and we decided to add 3 columns, then we're wasting all that space because they don't have dependents yet. So those are some problems to solution number 1. The second solution will be to repeat the information for the employee for the number of dependents. Like for example, here in this approach, column dependents, we can only store the information for 1 dependent. So in this case, this is the information for dependent number 1, but now Bob, because it has 2 dependents, we're repeating the same information, and then this is the second dependent. So now, we see that, for example, for the Bill, we're repeating that information 3 times because they have 3 dependents, and if we have somebody that doesn't have a dependent, we're also going to be wasting that space. And we can also see some problems here. So there will be a lot of redundancy because we're duplicating the data. And then there is a problem of potential inconsistency. The inconsistency is in the case because we're going to be inserting the same data multiple times. I may have a problem For example, adding the information of bill that is inconsistent. I maybe having a problem of maybe misspelling the name or having an issue, a typo or something there. So that's another possible issue. Third possible solution that we have is creating another table. So look at that this approach is now having two possible tables, and in one of the tables, we have the information for only employees. And the second table contains the information for dependents. Now, going back to the previous issues that we were discussing, like I say, let's suppose that this company, most of the employees don't have dependents. For example, in that case, we're not using any space on the table dependents because we're only using the space if somebody has a dependent. Like for example, for this social security number that matches this number, that means there is a dependent. But if we have an employee that doesn't have a dependent, then we will not see the social security number in this table. So this will be a good solution that we will explore in later topics when we talk about normalization. Now, again, we're studying 4 rules for relational database systems, right? So rule number 2 is a very important rule because it's going to derive some of the important concepts for this class. That is going to be primary keys and candidate keys. So the rule basically says that when we have a table, we cannot have in that table 2 rows with the same data. I just say that some of the concepts that will be important is the concept of a super key. So the super key in a relation, or remember another way of calling that is also a table, is going to be a set of attributes. Those set of attributes we're going to use to uniquely identify other a specific tuple on a specific row in a table. We're also going to have a concept of a foreign key that is also going to be a set of attributes that within that key, they are not the primary key, but they are key in another table. And we're also going to study more about foreign keys in a later lecture. Okay, so now let's explore the concept of super key with the data that we have in this table. So for this table, we see that we have 4 attributes. So we have attributes A, B, C, and D, and this is an instance of that we have for the table. Now, when we say that a super key was a set of attributes, in this case, because we had 4, we know that there will be 2 to the power of the number of attributes that we have in the table, which in this case is 4. So we have 16 possible subsets that we can generate with, or combinations that we can have with A, B, C, and D. This is including the empty set. So the empty set is going to be eliminated because we have to have at least 1 attribute. Now, when I'm exploring the set of attributes that will uniquely identify a specific row in the table, I could start with the ones, the combinations of the subsets from A, B, C, and D that has length 1. That means only contain 1 attribute. So that would be the case of just A. By looking at attribute A, I see that there is an A1 here. So A1 does not uniquely help me to identify just 1 row because I have another A1 too. So I have a problem there. That doesn't uniquely identify only 1 record. So A is not a good choice to be a super key. Then I go and check for B. B, I have another problem here. I have a B1 here and I have a B1 over here. So that's a problem there. It's not going to help me to uniquely identify 1. And it's the same problem we see, and it's even worse with D because the Ds, they are all the same. There is no way that D will help me to differentiate any one of those rows. Then none of these work. Then if I check for the combination of A and B, then here I have the A1, and I here have the A1 that was a problem before. But now the A1 with the B1 makes a difference with the A1 and the B2. Now it's not the same thing. Even though the A1 is here and the A1 is here, the B1 combined with that value makes that difference. So then it looks that this will uniquely identify one, because here I got the A2 and the A2, but there is an A2 with a B2, and this is an A2 with a B1. So that helps. Yes, that's a possible combination. Now, notice that if I add to this one that I already discovered to be a super key, if I add an additional attribute like C or even D. When I say even D, because I just say that D wasn't good to make a difference, right? Because they're all D1, 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 D1. But adding that D1 to the existing combination of A1, B1, and D1, we don't lose that uniqueness about identifying that specific row, right? So it doesn't hurt to have that extra attribute there. Okay, then we have some claims related with what we just been studying. One of those is we have to have for sure at least one, because the rule says that we don't have duplicates. So when we said at least one, it's because at least A, B, C, and D together, all four, for sure will be a super key, because of the rule says that we cannot repeat the value. So this combination cannot repeat. So that's what we said, at least we're going to have one. Now, I also show you, and I hope you notice that by adding an additional attribute to the existing super key, this is still a key. So that wasn't an issue. That wasn't a problem. Okay, now the next important concept that we have is the concept of a key. So most people just call it key, but I prefer that we make a reference to this as candidate key. Okay, so when I say candidate key or just key, it's about this concept. So this is still a super key. So there are two properties that we have for the candidate key. This is the one that we just discussed. But then the second property will be that there will be not proper subset from the candidate key that still has the property of a super key. So going back to the example that we discussed here, these examples, we know that A and B is a super key. But I also said about A, B, and C. So a proper subset of A, B, and C is A and B. So this is not allowed in a candidate key. So from that analysis, by looking into all possible candidate keys, we will notice that then A and B, like we just say, A and C, and B and C, will be from all possible combinations of super keys, that the only two that will be candidate keys. Why? Because we cannot drop a single attribute from them and still maintain the key property. So let's say this one. Dropping means, in this case, that I don't have the C. If I don't have the C, then I'm going to have the B. And we notice in the example that B by itself wasn't a key, and the same B, C by itself. So we need the two of them to be together to have that property. Now, this also makes a reference to minimality property, because we're basically talking about a super key that has the minimum set of attributes combined. Like in this case, in this example, this is not the minimum number of attributes to be a key, right? So that's what we have, that property there, here. In the example that we were just discussing here, I have three possible candidate keys, right? A, B, A, C, and B, C. So there are three. Now, when we will define tables for our system, we will have to create a table, and we're going to have to specify one of them to be the primary key. So that's what I'm calling candidates. So I had three candidates. From those, I, as the database administrator, I had to make a decision. I had to decide which one of those three will actually be the key, the primary key for the application. So then this is the one that is going to be chosen. This is the one that I will make a decision, and I may have a specific reason to decide. But still, I have to have a way of maintaining the candidate key, and we will discuss that when we're actually creating tables. But remember, so the primary key is going to be one of the candidate keys that is going to be selected. Now, rule number 3 specifies that once we have a primary key, we are not going to allow to have a null value on that. That means something that we didn't assign a value to a primary key. In my example, the only example that we have in this course about employees, we were using a good attribute there to be a candidate key, the social security number, because the social security number will uniquely identify an employee. What this rule says is when I enter the employee data, it's not going to be allowed if the social security number is the one that is going to be used as the primary key to have a null value. That means it's not okay that I don't know the social security number and I still enter that information into the data. So that is not allowed. That's what rule number 3 says. It says I had to have a value for that. Now, we say something about foreign keys previously, that we say that we will be attributes within the table that will be primary keys in a different table. And in the last rule, what this says is that for foreign keys, it's going to be okay if we use null values, like we don't have the information. Going back to employees, like for example, I know it's going to work for a specific department, or maybe it's going to be assigned on a specific project, but I don't have the information of that project, or I don't have the identifier for that specific department. And the identifier, what I mean is that it's going to be a key in department, but in employee it's going to be a foreign key. So it is okay that I don't have that and then I assign a null value. But it's not okay that I assign a department that doesn't exist. So if I assign a value to that specific key, it has to have a matching value in the other table. Be sure that in this video, you understand that we were studying 4 rules. So rule number 1 was 1NF. Rule number 2 was about not duplicate roles we can have. Rule number 3 is the entity integrity rule. And rule number 4 was about the referential integrity rule. Now, from those 4 rules, there are 3 important concepts that we need to keep in mind that we're going to be using for the rest of the semester. So it's the concept of a superkey, the concept of a candidate key, and the concept of foreign key. So be sure that those concepts are okay, and you also consult your references for additional information.